Section 6.1 Probability distributions are models of random experiments. For these sessions, we're going to talk about two types of the data, the discrete and the continuous. And we'll be introduce the probability distribution, and we'll be using the probability distribution to find the probabilities. First, two types of numerical data. Under the numerical data, we do have the discrete numerical values that you can list or count. So that's a data you can do that by counting. For example, number of the fingers. I can count 1, 2, 3, 4, 5, right? Or number of siblings, number of songs on an MP3 player. Okay, this is gonna be the discrete numerical values. Second one, continuous outcomes cannot be list or count because they occur over a range of values. For the continuous, that will be by measuring. For example, the height of basketball players, the weight of a sandwich. Those data you can do by counting. You have to measure it. So this is gonna be continuous. So remember on the chapter 1, we talk about the types of data. We have a numerical that consists of numbers and categorical that consists of names or labels. And under the numerical data, we have a discrete that's by counting and continuous that's by measuring. Okay, right? So for these sessions, we're gonna be focusing on discrete and continuous. Example, label each of these variables as discrete or continuous. Try to do it by yourself. Just make sure you remember that the discrete, that's by counting, continuous, that's by measuring. Okay, number 1, number of cars owned by a household. So number of cars you can count, right? How many cars do you have? So that's discrete. Number of pets you own by a student. So also you can do the counting. How many pets do you have? Discrete. Time it takes a worker to commute to a job site. So the time you can count the time, right? That will be continuous. The height of the building in downtown San Francisco. Also, that's by measuring. So continuous. Easy, right? Okay, probability distribution, a table or graph that tell us. So remember the distribution, this word we learned the frequency distribution. Usually when you have a distribution, we'll be using the table or graph to represent it. What is a probability distribution? All the possible outcome of a random experiment. So we could perform an experiment and then we're gonna write down all the possible outcomes, what you can get from that experiment. And then from the table, you can find the probability of each outcome. Okay, so you're gonna write down what is the probability for each of the outcome for your random experiment. That's called the probability distributions. For example, a random variable, typically represented by x, is a numerical outcome of a probability experiment. So we're gonna let x be the numerical outcome. For example, I'm rolling a fair 6-sided die. Okay, I have a 6-sided die here, and then the x, that will be represent the numerical outcome. So think about it. When you roll a fair 6-sided die, what you can get? You can get 1, 2, 3, 4, 5, 6. Okay, so this is gonna be the outcome of your experiment. And what is the probability? So think about it. When I roll the 6-sided die, what is the probability to get the 1? So that's a basic probability, right? So that'll be 1 out of 6. Same idea for each number, right? Probability of 2, that's also 1 over 6. So that's we just create the probability distribution. Okay, what is the probability of rolling a 5 or a 6? So when I'm rolling a fair 6-sided die, what is the probability to get these two numbers, 5 or 6? So we do have a 2 outcome out of 6 outcome. So that will be 2 over 6, which is going to be 1/3. We also can use the graph to represent the probability distribution. So you could see this as the number of stars. That will be your variable x here. And the y-axis here, this is represent the probability. Example 1. Estimate the probability that a randomly select reviewer gave this book a 3 stars rating. So we do have the probability distribution with the graph. Can you guys convert it to the table? The x represents the number of the star here. So we do have the first one. What is the probability of 1 in here? You only can estimate the numbers in here, okay? So this is going to be 0.01. And then we do have a 2 star, and probability is about 0.02. And then 3 star, we do have a probability of 0.11. 4 star, that will be 0.24. 5 star, we do have 0.62. Okay, hey, you may say, hey, how can I get like exactly that number? For the probability distribution, we do have the requirement. We're going to talk about it for the next slide. Now we're going to answer the question first. What is the probability of 3 star rating? That will be 0.11. Okay? Okay, two features of a probability distribution. Let the probability of x denote the probability that a random variable has the value x. Then, first, each probability, it has to be in between 0 and 1. Okay, you're gonna double check here. Each probability is between 0 and 1, between 0 and 1, between 0 and 1. Okay, so this is gonna be the first requirement. Second, when you add up all the probabilities, it has to be equal to 1. So you could try add up all the probabilities here. It has to be equal to 1 here. Okay? So this is the two requirement. And actually, that's a one more, and I don't think they stated in here. The outcome has to be numerical. So this is the numerical probability distribution. So the outcome has to be numerical. Okay? Okay, so from the number 2 requirement, when you add up all the probability, it has to be equal to 1. So meaning that when you add up this here, it has to be equal to 1. So you guys can plug it in, find out what is the probability of 3 here. Obviously, it's also equal to 1 over 6. Right? So make sure you guys remember this requirement. Highlight it. I may ask you guys for the midterm too. Creating a probability distribution. Suppose you roll a fair 6-sided die. You win $10 if you roll a 5 or a 6. You lose $5 if you roll a 1. For any other outcome, you win or lose nothing. Create a table showing the probability distribution for the amount of money you win playing this game. So think about it. This is my random variable of x. X will be equal to 10 when you roll a 5 or 6. And x will be equal to -5 because you lose money, right? When you roll a 1. For any other outcome, you win or lose nothing. Means your x is gonna be equal to 0. Okay? So one more time. How can you win $10? When you roll a die with 5 or a 6. How can you lose $5? when you roll a 1, right? How about this one? How can you win or lose nothing? When you roll the die with 2 and 3 and 4. Okay, so that will be your possible outcome. This is what you guys roll the number and get the possible outcomes. So think about it, probability of rolling a 1. What is the probability to get the 1? You do have 1 out of 6, so that will be 1 over 6. Probability of win and lose nothing by rolling a 2, 3, 4. So probability to get 2 or 3 or 4, that will be 3 out of 6. Last one. Think about it. Probability of rolling a 5 or 6, that will be 2 out of 6 here. Okay, right? Now we have all the information for your probability distribution. We have the x here. We have all the probability. So x can be -5, 0, and 10. One more time, what is the probability to get the -5? That will be 1 over 6. 0 will be 3 over 6. And the last one, that will be 2 over 6. So this is gonna be my probability distribution. And double check with the requirement. First, x has to be numerical outcome. Good. And each of the probability has to be in between 0 and 1. And last, when you add up all the probabilities, it has to be equal to 1, right? So that will be 4 plus 2, 6, 6 over 6, which is going to be equal to 1. Okay, it fulfills all the requirement for the probability distribution. So this is a discrete random variable with the probability distributions. Second part, probability distribution for continuous random variable. Because you cannot list all the outcomes for a continuous random variable, we cannot represent the probability distribution using a table. So remember continuous random variable, that's by measuring. For example, the height of the basketball player, you can list all the outcome or probability using the table. So we'll be using the graph. This is called probability density curve. I use instead of using the table. And this is the requirement for the probability distribution for continuous random variable. First, total area under the curve must be equal to 1. And then the curve cannot be fall below the x-axis. So look at these two pictures. This is the normal distribution, the bell shape, right? And this graph is represent for the continuous random variable. It fulfills these two requirements. The total area under the curve. So, okay, the area under the curve is going to be the bell shape here. That has to be equal to 1. And the curve cannot fall below the x-axis. It's always above the x-axis in here. And this one, this is the uniform distribution. This is represent the continuous random variables as well. Same idea. The area under the curve has to be equal to 1. Okay, this part here, the area under the curve must be equal to 1. Second, the graph, this graph, cannot fall below the x-axis. Okay? So first, let's talk about the uniform distribution. A continuous random variable has a uniform distribution if its values are spread evenly over the range of possibilities. The graph of uniform distribution results in a rectangular shape. Okay, we talked about this guy already, uniform distribution, right? The probability is about the same in here. So it creates a rectangle shape here. The area under the curve has to be equal to 1. Remember, this is one of the requirements. area under the curve has to be equal to 1. And there is a correspondence between area and probability, or relative frequency. So some probabilities can be found by identifying the corresponding areas in the graph. So I want you guys to write it down. This is talking about area equal to probability. So every time for the uniform distribution, when they say find the probability, means they are looking for the area. Okay, one more time. Area equal to probability. So every time when we're looking for the probability in the uniform distribution, means we are looking for the area. Okay? And we need to know how to figure out the height of the rectangle in here. So think about it. Area of the rectangle will be equal to the base times the height. You guys learned it from the algebra. The base times the height will be equal to the area of the rectangle. And we already know area of the rectangle equal to 1. What is the base? Base will be the b minus the a. And then the height will be the h. So I have this formula here. And we are looking for the h. So we're gonna divide it by b minus a for both sides. Simplify it. So h, that will be equal to 1 over b minus a. Okay, I need you guys remember this part as well. How you guys finding the height of the rectangle? Okay, try this example. On average, 30 minutes TV shows have 22 minutes of actual program. Let's assume the probability distribution for number of minutes of actual program is uniformly distributed from a low of 18 minutes to a high of 26 minutes. So for this example, I want you guys highlight uniformly distributed. Highlight this one, uniformly distributed. Every time when you see the uniform distributions, you're gonna remember this picture, the rectangular shape here. Okay, so A, graph the probability distribution. I want you guys to have the picture, state the lowest value, highest value, and the height of the rectangle. So, uniformly distributed, I already know this is going to be the rectangular shape. So think about it. What is the lowest value? They say uniformly distributed from a low of 18 minutes to a high of 26 minutes. So that's 18 and 26. Now you want to figure out the h in here. What is the height of the rectangle here? So we could use the formula 1 over b minus a. That will be 1 over 8. Okay, one more time. This formula, 1 over b minus a. Okay, right? This is the probability distribution. B, what is the probability? P of x, the show will have greater than 25 minutes of programming. So first, graph the probability distribution. We already have this picture. And then they want to find the probability that greater than 25 minutes of programming. So 25 is somewhere like here. Greater than. So it's talking about this side here. And remember I say every time when they're looking for the probability means they're looking for the area. So this is means find the area of the show that's greater than 25 minutes. So talking about this part here. Okay, so P greater than 25 minutes, we'll be using the formula, the base times the height. The base here, that will be 26 minus 25 times the height, which is going to be 1 over 8. Okay, so that's the 0.125. Okay, C. What is the probability the show will have between 21 and 25 minutes of programming? So again, I have this picture. I want you guys try to do it by yourself. So 21 to 25, we are looking for the area of this part. So that will be the base 25 minus 21 times the height of the rectangle. So that will be 0.5. Okay, so this example will be higher chance on your midterm too. Okay, so make sure you guys know how to do it and how to graph the probability distribution. Okay, example 4. A bus arrives at a certain stop every 12 minutes. The graph shows the probability distribution for wait times before the bus arrives. Use the distribution to find the probability of a wait time between 4 and 10 minutes. Okay, so this is what they're looking for. Find the probability means finding the area of a wait time between 4 to 10. So 4 is somewhere like here, 4 to 10. Okay, I will have this picture and I'm looking for the area of this rectangle. So probability between 4 to 10 will be the base times the height. So this is going to be 10 minus 4 times the height is 0.08353. So it's about 0.4998. It's going to be 0.50. Okay, right? Uniform distribution. Make sure you guys remember this picture. How to find the height of the rectangle and how to find the area of the rectangle here. And then keep in mind, probability will be equal to area. That's it.